interoperability, and governance. It really is a heterogeneous multi-chain proposal, a framework that is set to enable independent blockchains to exchange information and value in a trust-free manner. Now, for this larger vision to become a success, we need a component that we call the bridge. And the bridge in that context is supposed to enable blockchains that are self-securing, that means that provide their own means to come to consensus to really communicate with each other. Now, when we started with that project, we realized that we really got an opportunity to create value for existing Ethereum developers, rather than shooting for the moon in a few years. And in order to understand in what way this can help Ethereum developers today, it's important to understand the problem that we are facing today, those teams that are building dApps today. And I mean, most of you are aware that the name of the game is scaling, right? We still haven't figured out how Ethereum mainnet can scale. And I personally, at least, am very skeptical that Shaspa will arrive within the next 12 months, and I think it will rather take a few years until we really get there. And what we've seen over the last years is that we have this amazing ecosystem, like hundreds of projects that have been working hard on implementing certain dApps, right? Certain dApps with a certain smart contract architecture. And it's sad, but the reality is that a lot of them can't go live today on mainnet because transaction fees are prohibitively low, prohibitively high, so the dApps are economically not feasible. And second, we get into these situations where the network is just congested, right? The blocks are full. And some people may say, right, but we have all these other EVM scaling approaches, right, that can potentially help us today or rather in a few months when they're done. And a lot of them we call layer 2 scaling solutions, right? So we have one-to-one micropayment channels such as MicroRaven, or we have state channel approaches from the wonderful team from Funfair, the general state channels from Counterfactual, or the great work that SpanChain has been doing. And last but not least, there's Plasma, right? But what a lot of people forget is that those approaches are not applicable to most dApp architectures that exist today. So these teams that have set out like a few years ago when these ideas weren't around yet, right, and have written like hundreds and thousands of lines of code, right, are in a situation where they're like, if we want to use these approaches, these layer 2 scaling approaches, that really means they have to start from ground zero. They have to re-architect their whole dApp. So, and that is where I believe Parity Bridge can at least help in the intermediate time until Shasta is around, right? So let me introduce you to what that is, Parity Bridge. Basically, it's a federated system that allows to relay arbitrary messages, any kind of messages between two EVM networks, between two EVM chains. For the sake of this presentation here, let them call them main and sidechain, right? So we have two. There are three critical parts of that bridge that exist today. One is the Rust software that connects to two Ethereum nodes via RPC or IPC, you can choose, and really just watches the chain for certain events to be triggered. Then second, there are meat space entities, persons, that run the aforementioned software. And they are the authorities that validate and eventually relay the messages from one chain to another. And last but not least, we have smart contracts on both chains that coordinate between these authorities, the validation, the relay, and eventual delivery of the messages. Now, what can you do with them, right? That's the biggest question. Well, The nice thing about that is this general approach is that you can have a Dapp that has a smart contract on one chain that suddenly calls a function on any contract with any parameters on another chain. It's that simple. And security of that message relay is guaranteed by trustworthy authorities. So for every and each message that's being relayed, it's required that a certain number of authorities have signed off of that message relay. And overall, we try to keep the system as simple and general as possible. Right? Now, how can that help mitigate these scaling issues that we run into? Well, if you can offload a large amount of transactions from one chain to another, right? That is an approach you can choose. And really what you can do there now, because of this arbitrary message relay approach, is you can spread out your Dapp between those multiple chains. So you have the assets that need to live on mainnet, right, on the Ethereum mainnet. Maybe those that have to be interact with exchanges, or maybe some identity of the user. That can stay where it is, right? But those interactions within the app that happens on-chain, right, that are really computationally expensive or require a lot of transactions, those you try to outsource to another app. So that's one part. The other exciting part about that approach is, in my opinion, that you can really get early access to new features. Features that have yet to become available on the mainnet. So if you take as an example that the sidechain is being run by Parity Ethereum nodes, right, in a POA network. You could have today WASM smart contracts being run there. You could use private transactions. Or you could try out Constantinople opcodes that will only become available in half a year in January when the Ethereum mainnet upgrades. There's one note of caution I wanna add here. And that's very important to me. While this is really great for the moment, in the long run, this isn't gonna solve the scaling issue in the whole, right? That's why the slide said mitigating scaling issues and not solving them. Because what that means here is that, you know, if you spin up a new sidechain, that means you also have to secure that sidechain. And as more sidechains there are, as more resources you need to secure these individual sidechains. And we all believe that that can't scale securely. Nonetheless, in the meantime, this is a way to get your application live. So, for the sidechains, what options do we have? I believe you can choose between three flavors right now. Either you say, hey, you know, I need all the transactions throughput that's available on a new chain for myself, for my own app. In POA, Parity Ethereum, you can get up to maybe 500, maybe 1,000 to 2,000 transactions per second. And then you just say like, hey, I spin up my own Dapp specific chain. You get a few befriended projects to run an authority node and thereby secure your chain. Or you say, no, actually, you know, there's this other team and we have like applications that interface with each other, that are relying on each other, and we both make a consortium and we spin up our kind of Dapp, friends of Dapp's chain. Or last but not least, you use an existing bridge that bridges existing networks, for example, the Ethereum main network with the Coven testnet. Now, let's take a look how Parity Bridge actually works. The next few slides will show you a walkthrough for a message being sent from main to send. What you can see in these diagrams is on the left side, there's the main chain, on the right side, there's a side chain. On the main chain, you have a contract deployed that's called bridge contract right now. It has one function that's called relay message. On the sidechain, you have a bridge contract as well, right? And it has a function called confirm message. Now, some app wants to use this bridge. What the Dapp does, it deploys extension contracts. So contracts that know how to interact with these bridge contracts. So we have on the left side, sending contract, which is part of your Dapp. It has some function. And on the right side, we have on the sidechain a receiving contract, which is also part of your application, and which has a function accept message. Now, we also have bridge authorities, right? This integral part of the system that actually facilitates the message relay between the two chains and that watches both chains. Now, let's say a user kicks off a transaction with your application, it calls some function, and some function again calls relay message because it wants to send over a message to the other chain. That again kicks off, it triggers an event called relay message. The bridge authorities see that event being triggered. They wait a few confirmations because they want to wait until they have a higher degree of finality, right? Because the mainnet has only probabilistic finality, and you really don't want to relay a message that might be reverted after the fact, right? So after a few block confirmations, the authorities confirm the message one by one on the other chain. Once a certain threshold, which is configurable, has been achieved, another event is triggered, which is receive message, and then this contract, the bridge contract on site, calls whatever the recipient contract is, and calls a function called accept message there. That's it. Message delivered, and there can be whatever transaction should be kicked off by this interaction can be kicked off by accept message. So, that said, the message relay, the other way around, from site to main, is not identical to this interaction. And that is mainly due to the reason that we build on the assumption that transaction costs are significantly higher on the main side than the side side. And that means, bridge authorities really want to interact as little as possible with the main blockchain and gather signatures, gather these confirmations on the sidechain. So, how can you utilize it as a Dapp developer? What do you have to implement? Critically, there are two interfaces that you need to be aware of. You can see both here. One allows you to relay a message. It only has two parameters. It's the data, whatever your message is, as well as an address, which is a recipient address on the other chain. Also, you have a function called accept message, which your recipient contract has to implement, right? And that's it. One thing is to be noted here. All information obviously needs to be encoded in the data parameter. And the recipient contract needs to be able to decode that message and do certain actions based on this decodation. Now, I brought you a few examples of what you can do with them. So, for example, you can use it to build an ERC20 to ERC20 bridge. You log up, you build for example, let's take Augur as an example. You build a contract that allows you to log up Augur on REP on the mainnet. That contract sends a message through the bridge to another contract on the side network and says, hey, assign that many Augur tokens that only live on the side network to this person, and vice versa. Pretty straightforward. As well, you can do that with native currency. So on the mainnet, you could log up Ether on one side and create wrapped Ether on the other side, which is really an ERC20 token that is redeemable for one Ether on the main network. And the last example I brought here, and that's the one I'm most excited about probably in this compilation here, is that you can have an ERC20 token on the main network, lock it up, and then give the user, whoever locked it up, native currency on the side network. And that really means you suddenly can have a stablecoin tech native currency on the sidechain, right? You can have DAI being essentially the currency that you use to pay for gas on your side network. And if you combine that, for example, with fixed gas prices, you suddenly have a situation where those people that run dApps or those people that interact with dApps on your side network have full control and full understanding of what their transaction and their interactions will cost. There will be no volatility. And this last part really was made possible by something we call block reward contract, which allows a smart contract to inform the consensus engine how many new tokens should be minted and who they should be assigned to. But basically, the options are pretty much unlimited of what you can do. Everything you can write in a smart contract, you can do that. Now, here are a few of the projects I've personally talked to that have either been using the Parity bridge or that have been waiting for the arbitrary message passing in order to, you know, split up their dApp between multiple chains. Now, as always, there are certain caveats with this approach. And there are certain caveats with our current implementation that I don't want to not talk about. So, number one, currently all of the bridge authorities, right, these authorities that relay messages, should also be authorities on the side network. So they should be the validators, the block producers of new blocks on the sidechain. That is because currently the system is designed so that most transactions that happen on-chain happen on the side network. And you don't want the authorities to have to pay for all these transactions, right? For both reasons, spam protection as well as cost. But if the bridge authorities happen to be the POA authorities on the side network, they don't have to pay for the transaction that they put in their blocks. So that works pretty well. In my opinion, it also works pretty well with the trust model that you have to assume around this application. Because, you know, after all, if you don't trust the authorities on your side network to, you know, truthfully maintain integrity of this sidechain, right, then you also wouldn't want to trust a bridge that relays messages to this chain. Right. Another one currently the bridge authority set is immutable, right? It's very trivial to change that. We can just add another contract logic that allows you to have a majority vote and vote a bridge authority in or out however you want, or add whatever else governance mechanism you want. Last but not least, if you connect two chains and one of the chains is a proof of work network, then unfortunately you are facing the problem that you don't have deterministic finality, which means if you want to be fairly sure that nothing is being reverted, you want to wait a few transactions. And that introduces latency that we don't want. That said, if you got two networks that have deterministic finality, there's really no reason to wait longer than once finality has been achieved on any block. Last but not least, there's a very important note of caution here. The contracts I've been talking about here, they haven't been audited yet. So please use with caution, they're in an alpha phase, right? So, further challenges. Transactions on mainnet are very expensive, right? So, if you relay a transaction from the side network back to the main network, then you need at least one transaction to be made by authorities. And that's the transaction that actually relays the message, right? So, now, who should pay for that transaction? That's still a problem we're facing. I believe in most cases it won't be a big problem because the application that decides to implement the side network and to utilize the bridge has an intrinsic motivation to pay for these transactions. because it obviously increased the value of the network, the overall network, and its application. Second, what happens when a relay message kicks off a transaction that actually runs out of gas, right? Like, we are facing a more async situation here, and that's not trivial at all to mitigate. Another thing that shouldn't be unnoted is that there is still missing tooling for sidechains, right? Even though we finally have an open source blockchain explorer, which is absolutely fantastic, right? Which you can spin up for your side network, we still miss MetaMask and Inferior and other kind of things that we usually want in order to effectively build on a network. Last but not least, there are UX considerations that you have to take into account when you follow this approach. For example, you might end up in a situation where the user that interacts with your Dapp has to switch between networks, which is not quite nice. Also, the user might have to own native currencies on both networks. So, last thing, a bit about the roadmap that we're looking at. Next things we want to do include, we want to enable bridge authorities to vote on a new bridge authority set. What I just said, dynamic bridge authority sets. Second, what we really want is that the bridge authorities are tracking whoever is an authority on the side networks, and that these sets are pretty much identical. Further, we are exploring methods how the side network can be proof of stake, and the sidechain validators, the validators of that chain actually stake ETH on the mainnet, which is a fairly interesting approach. Furthermore, we are interested in finding more interesting use cases, writing more extension contracts, and last but not least, there's still tooling that should be in place. For example, monitoring tooling that allows us really to inspect and see what is happening in the bridge and what messages are being relayed, and debug problems if there are any problems. I invite all of you to please have a look at our wiki, read, contribute, chat with us. I can't wait to hear what you want to build with us and on what network you want to build it. Is it Coven? Is it your own app for specific chains? Are you going to team up with Giveth or some other teams to build a new chain in the meantime, as long as the mainnet doesn't scale? Thank you so much. So I've got another 5 minutes for questions. I can repeat it to you though.
On the roadmap, I noticed you guys had no intention to audit your contracts. Is that something that you're going to do?
I can.
On the